Welcome to the MSBT online learning platform. We bring you the most relevant content in exciting digital format. Today we will be studying a very interesting module for applied mathematics, that is differential calculus, which includes topic derivatives 2, where we will be studying some interesting facts about derivatives and we will be practicing some of the example based on it. So let us begin. Now our module is differential calculus and topic is derivatives. Students be able to use chain rule of derivatives to solve the example of composite functions. Learning outcomes. Our learning outcomes are: understand the idea of differentiation from first principle of derivative. Second, understand the idea to solve the examples based on different rules of derivatives. Before proceeding towards the composite function, I would like to define the word composite. Nowadays, composite culture is very common in mega cities. All of us know what is the sense of composite culture. When the people of different cultures are living together without any discrimination, evolving a new culture, keeping their own culture intact, then such a culture is known as composite culture. Likewise, in case of composite function, if two and more functions are clubbed together, joined together, then such a combination of the function and its resultant is known as composite function. You see, if f and g are two different functions from the set A to set B and set B to set C respectively, then the function from set A to set C is known as composite function, and written as f of g x is a function from set A to set C, and f of gx is always equal to f of gx. Now, without going in detail, I would like to put one example to solve the problems based on composite function easy for you. Look at the question. Your question is y is equal to log sine tan inverse x and whole raised to 3 upon 2, and there is a fish. There is significance of fish at that place. All over the world, there is the same culture of fish market. When we go to the fish market to purchase the fish, first of all we choose the fish of our choice, then we say to the fish seller, please clean it and cut it into pieces. What to clean? When we say to clean, they clean the fin and siphons of the fish. Then they start cutting the fish into pieces. How they cut it? You see. Anywhere in the world, all the fish sailor start cutting the fish from head side and they come gradually up to the tail. And what is the relation? This fish cleaning and cutting to the given function y is equal to log sine tan inverse x whole raised to 3 upon 2. Here in this example, whenever you are solving the problem of composite function means where two and more functions are clubbed together. Here in this example, there is a log, that is a log function, sine trigonometrical function, tan inverse x is an inverse function, along with the index 3 upon 2. You always take the index as a head. That means you have to differentiate, you have to cut 3 upon 2 first. That's why you know how to find the derivative of index, because you have one formula, that is the first formula, derivative of x raised to n is equal to n x raised to n minus 1. So, first of all, in case of composite function, you find the derivative of the index, then you start from the head side, that is the first function, that is log sine tan inverse x. You know, derivative of log x is 1 upon x, that's why here in this case, it is log 1 upon sine tan inverse x. Again, there is a sine, that is another function, and we know the derivative of sine is cos, that's why into cos tan inverse x. Again, there is other function, that is inverse function, that is tan inverse x. That's why we have to take the derivative of tan inverse x, that is 1 upon 1 plus x square. Therefore, to find the derivative of composite function, you have to start from the index and go gradually towards the last function. That is the best example for you to solve the problems of composite function, always keeping the fish in your mind. Now at this stage, I am Professor Kale to come and solve few problems based on composite function, so you can get your confidence boosted.
Thank you, sir. So students, Haq sir explained beautifully the concept of composite function. Now, in general, composite function is defined as f of g of x. For example, log of ax plus b. Now here, log, the first function f, and g of x is ax plus b. The logarithmic function including algebraic function. In another, sine of ax plus b. F is sine and gx is ax plus b. Similarly, tan ax plus b, e raised to x plus b, these are the examples of a composite function. Now here we see actual differentiation process for composite function. For differentiation of composite function, we use chain rule called as chain rule for differentiation. Now the method, d by dx of f of ax plus b. So how you differentiate? First we take the first function f, derivative of first function, d by dx of ax plus b, then again derivative of ax plus b. That means first you take the derivative of outer function and then you take the derivative of inner function. What is our outer function here? F. Outer function, first function. And what is the inner function? This is ax plus b. Remember students, the sign in between these two derivatives is into, not addition, subtraction. So remember, derivative of first f of ax plus b into derivative of ax plus b. Now, in another case, instead of ax plus b, just I am putting g of x. D by dx of f of g of x. In the similar way, how you differentiate? First we take derivative of f of g of x and again we take the derivative of only g of x. Now here we see derivatives of some composite function. D by dx of ax plus b raised to n. Remember, in the previous case, we have to find out the derivative of x raised to n. Now what is the difference in the derivative of x raised to n and derivative of ax plus b raised to n? So for comparison, just I am write down here the derivative of x raised to n. Now x raised to n, we have to say it is a simple function, and ax plus b raised to n, we have to say it is a composite function. The coefficient of x is in the previous one is 1 and here the coefficient of x is other than 1. Now d by dx of ax plus b raised to n, we have to use the same rule just like a previous one. First I am taking the derivative of ax plus b raised to n. Haq sir already told us we have to take the index part of the fish first. So here what is the index part of the fish? This is index raised to n. We start derivative raised to n. That means x raised to n, we take the derivative first and after then you take the derivative of x plus b. So d by dx of ax plus b raised to n into again derivative of ax plus b. In another case, what is our first function? Our first function is sine ax plus b. What is again another function? This is the algebraic function ax plus b. Now student, you tell me how you differentiate sin ax plus b. Correct. First we take the derivative of sin x plus b, that is the outer function, main function sin, and then you take the derivative of inner function, that is ax plus b. Similarly, derivative of sin inverse of ax plus b. So what is the outer function? Correct, sin inverse. So sin inverse ax plus b, and then again take the derivative of ax plus b. Similarly, derivative of log of ax plus b. First take the derivative of log of ax plus b, and then again take the derivative of ax plus b, and this is called the chain rule of differentiation. Again one example I explain here, d by dx of e raised to ax plus b. So first you take the derivative of this exponential function, and then you take the derivative of algebraic functions. Now for example, y is equal to log of sin x. Log function के अंदर sin है, यानी first is log and then is sin. That means how you differentiate this log of sin x? First you take the derivative of log of sin x, and then you take the derivative of sin x. How you differentiate log of sin x? This is just like log x. What is the derivative of log x? It is 1 upon x. So instead of x you have to imagine now sin x. So how you remember? Derivative of log of sin x into again derivative of sin x. So just like log x, the derivative of log x is 1 upon x. So similarly the derivative of log of sin x is 1 upon sin x. See here, 1 upon sin x into again derivative of sin x is cos x. So then we get dy by dx equal to cos x upon sin x equal to cot x. Now see the another example, y equal to a raised to log x. Now students, just I am going to ask you what type of this function. You already learnt about this function in the previous case, that is in the simple type of function. So tell me what is the type of this function. Correct. This is the exponential type of function. In the previous case, we learned the derivative of a raised to x. Similarly, now here we find out the derivative of a raised to log x. Category is same, but instead of x, they put log x. That means first function is exponential function and inside function is logarithmic function. So that's why we have to say that it is a logarithmic function. Now how you differentiate? Can anybody tell me how you apply the chain rule here? Yes? Very good. So let's see here. First you take the derivative of a raised to log x, and then you take the derivative of log x. This is called chain rule. So what is the derivative of a raised to log x? This is just like a raised to x. What is the derivative of a raised to x? A raised to x into log a. So in the same manner, we write down a raised to log x into log a, and again derivative of log x is 1 upon x. So finally, we get the answer dy by dx is equal to a raised to log x into log a into 1 upon x. Take another example, y is equal to cos of log x. Now you tell me, what is the first function here? Very good. So basically, first function is cos, another function is log. So it is a combination of cos and log. Now how you apply the chain rule here? Yes, you tell me. Very good. Dy by dx equal to d by dx of first is cos, not log. First function is cos, so that's why first we take the derivative of cos. Log x must be there. You don't put only cos x. It is with log x. So first you put the derivative of cos log x and then you take the derivative of log x. So what is the derivative of cos log x? Here the derivative of cos log x is only cos, the derivative is minus sin log x, and again derivative of log x is 1 upon x. Students, remember, I have seen so many times you put the derivative of cos is minus sin and at the same time you put the derivative of log x 1 upon x. So this is wrong. First you write down the derivative of cos is minus along with log x and into again derivative of log x is 1 upon x. These are the two different terms. Remember these things. Now take the another example. Y equal to 3x plus 2 raised to 3. So again first you see this is not a simple ax plus b. The power is given. So that means this is just like ax plus b raised to n. So first you see which one formula you have to use for differentiation here. Can anybody tell me? What is the type of this function? Correct. This is just like y equal to x raised to n. उस kind का ये function है. That means you think the derivative of x raised to n. Now this is just like ax plus b raised to n. So what is the derivative here? D by dx of 3x plus 2 raised to 3 and again derivative of 3x plus 2. Why we take again derivative of 3x plus 2? Because it is a composite function. In the previous case, suppose, imagine 3x plus 2 की जगह suppose x है. Then y equal to x cube. So we simply differentiate 3x raised to 3 minus 1. But instead of x, what is here? Here 3x plus 2 raised to 3. That means first you think only about this power just like x raised to n. So what we get? 3 bracket 3x plus 2 raised to 3 minus 1 into again derivative of 3x plus 2. Now here 3x plus 2 raised to 3 minus 1 is 2 and here 3. What is the derivative of x? It is 1 plus 2 is without x. 2 is without x, that means it is a pure constant and the derivative of pure constant is 0. Don't write the derivative of 3 is 0 into derivative of x is 1, then 1 into 3 into 0 into 1, that is 0. No, this is wrong. 3x, that means 3 with variable. So 3 is a constant, taking outside, then you take the derivative of x, plus 2 is without x, so that's why the derivative of 2 is 0. We get 3 into 3x plus 2 raised to 2 into 3. So finally 3 into 3, that is 9, 3x plus 2 whole square. Now take another example. Y is equal to third root of 1 minus x square. How you differentiate? Third root of 1 minus x square, that means 1 minus x square raised to 1 upon 3. This is just like ax plus b raised to n. Now see how we differentiate. dy by dx is equal to d by dx of third root of 1 minus x square into again the derivative of 1 minus x square. Now first we see third root of 1 minus x square is nothing but d by dx of 1 minus x square raised to 1 by 3 into, now 1 is alone without x, means what? That is 1 is constant and the derivative of 1 is 0. What about x square? Apply the formula x raised to n. 2 into x raised to 2 minus 1, that is 2x. So I am directly write down here the derivative of x square is 2x. So now here derivative of 1 minus x square raised to 1 by 3. Apply the formula. We get 1 by 3, 1 minus x square raised to 1 by 3 minus 1 into minus 2x. After calculation, we get this result, minus 2x upon 3, 1 minus x square raised to, take LCM, 1 minus 3 upon 3, and finally we get the answer, dy by dx equal to minus 2x upon 3, 1 minus x square raised to minus 2 upon 3. Now we see the examples on d by dx of fx raised to n. Now here I am writing the special function. This is not a special function, but that kind of examples I am going to explain here. So just I am write down here d by dx of fx raised to n. Fx is any function. It is algebraic, it is trigonometric, it is inverse trigonometric, it is logarithmic, any type of function is fx, but when raised to n is there, then how you differentiate this function? Now here we see the example, y equal to sin x raised to n. So our fx is sin x and n is 3. Now this is just like x raised to n. Here instead of fx we take sin x, then how you differentiate? 3 into sin x raised to 3 minus 1 into again derivative of sin x. So what we get? 3 into sin x raised to 2 into cos x. So finally we get the answer dy by dx is equal to 3 sin x square into derivative of sin x is cos x. Take another example. Y is equal to tan x raised to half, or we differentiate root of tan x is just like derivative of root x. What is the derivative of root x? It is 1 upon 2 root x. So here first you take the derivative of root x and then you take the derivative of tan x. So dy by dx is equal to 1 upon 2 root of tan x into again the derivative of tan x. So finally we get the answer dy by dx is equal to 1 upon 2 root of tan x into derivative of tan x is sec square x. This is the answer. Now another example, y is equal to 1 upon 2x plus 3. Now how we differentiate? So dy by dx is equal to d by dx of 1 upon 2x plus 3 into again derivative of 2x plus 3. Now remember here, derivative of 1 upon x is minus 1 upon x square. So it is minus 1 upon x square. So according by rule, we say that the derivative of 1 upon 2x plus 3 is minus 1 upon 2x plus 3 whole square into again derivative of 2x plus 3. So what is the derivative of 2x plus 3? It is 2 and 3 is without x. So that's why we have to say that it is a constant and the derivative of constant is 0. So finally we get the answer minus 2 upon 2x plus 3 whole square. Now another example, y is equal to log of sine of 4x minus 3. Starting function is log, then again inside function is sine, then again inside function is algebraic function, that is 4x minus 3. So it is a combination of 3 different function. First one is log, second one is sine and third one is 4x minus 3. तो सबसे पहले आप डेरिवेटिव किसके करेंगे बताइए? सबसे पहले हम डेरिवेटिव करेंगे log, उसके बाद हम डेरिवेटिव करेंगे sin, and lastly we take the derivative of 4x minus 3. But now we have to arrange in a proper way, in the form of a chain rule. Now let's see how we arrange. Now according by chain rule, first we write down d by dx of log of sine of 4x minus 3, then d by dx of sine of 4x minus 3, and then d by dx of 4x minus 3. So first we take derivative of log, keep sine 4x minus 3 as it is, then derivative of only sine, keep 4x minus 3 as it is, and lastly we take the derivative of 4x minus 3. So what is the derivative of log of 4x sine of 4x minus 3? It is 1 upon sine of 4x minus 3, because derivative of log x is 1 upon x. And instead of x, we have to imagine here sine of 4x minus 3. Then what is the derivative of sine x? It is cos x. So in second term, we get cos of 4x minus 3. And in the last term, 4 into x, that is derivative of 4 into x is 4 minus 0, that is the derivative of constant is 0. So finally we get the answer dy by dx is equal to 4 cos of 4x minus 3 upon sine 4x minus 3. Now another example. Y is equal to e raised to 7x into sine of 2x. Now this is a product rule. It is a multiplication of two different functions, but in this case we take composite function. E raised to x simple function, e raised to 7x composite function. Sin x simple function, sin 2x composite function. Now the process of differentiation using product rule is same, but here the derivative of e raised to 7x is different than e raised to x. So let's see. dy by dx is equal to, what is the product rule? First function into derivative of second plus, remember the sign, plus sin x into derivative of e raised to 7x. So e raised to 7x, now what is the derivative of sin 2x? Now you tell me what is the derivative of sin x and what is the derivative of sin 2x. Comparing these two derivatives, derivative of sin x is only cos x. But what is the derivative of sin 2x? Sin के अंदर 2x है, अकेला x नहीं है. So sin 2x का derivative cos 2x and again derivative of 2x. In the similarly e raised to 7x, x is not alone, it is with 7. So first derivative of e raised to 7x into again derivative of 7x. So tell me what is the result here? E raised to 7x cos 2x derivative of 2x plus sin 2x e raised to 7x first derivative and again we take the derivative of 7x. So finally we get the answer e raised to 7x into cos 2x derivative of 2x is 2 plus sin 2x into e raised to 7x and again derivative of 7x is 7. The final answer is this. Now students, we see another example for inverse trigonometric function. Now here y is equal to sine inverse of x. What x raised to? No, it is not 0. It is called degree. So many students write down x raised to 0 is 1 and they find out the derivative of sine inverse 1 also. So this is totally wrong. X degree, first you have to convert it into radian and then you differentiate. So see here, x degree is equal to x pi upon 180 radian. So how we write it? Sine inverse of x degree in terms of radian, d by dx of sine inverse x pi upon 180. Now how you differentiate? What is the derivative of sine inverse x? The derivative of sine inverse x is 1 upon root of 1 minus x square. But instead of x, what is here? Instead of x, it is x pi upon 180. So rule is same, but instead of x you write down x pi upon 180 and it is a composite function. That's why we take again a derivative of x pi upon 180. So finally 1 upon root of 1 minus x pi upon 180 whole square into again derivative of x pi upon 180. So students, remember here pi upon 180 is a constant term. So that's why pi upon 180 you take it outside and we take only derivative of x. So the answer is 1 upon root of 1 minus x pi upon 180 whole square into pi upon 180. This is a very important example asking so many times in the examination. So final answer. Now we are coming on the derivatives of inverse trigonometric function. So before we see some useful result for inverse trigonometric function, because these rules are very important at the time of differentiation. Now we know that sine inverse of sine x is x, cos inverse of cos x is x, tan inverse of tan x is x. Similarly, sine of sine inverse of x is x, tan of tan inverse of x is x, cot of cot inverse of x is x. The third rule, sine inverse of minus x Sine inverse of minus x is minus cos inverse minus sine inverse x. Tan inverse of minus x is minus tan inverse x. Again the result, this formula is very, very important. Tan inverse x plus tan inverse y equal to tan inverse x plus y upon 1 minus xy when the product of xy is less than 1. If xy is less than 1, then denominator should be negative. Denominator is always positive, so that's why we put xy is less than 1. In another case, tan inverse x plus tan inverse y equal to tan inverse x minus y upon 1 plus xy. In this case, xy is greater than 1, no problem. Less than 1, no problem. Now, seventh one, cos of 90 minus x is sin x. So, similarly, you know the other formulas. Sin of 90 minus x is cos x. Tan of 90 minus x is cot x. Cot of 90 minus x is tan x. So, you remember all these results. You already learned all these results in first semester. Now, we take some examples. Y is equal to sin inverse of cos x. You directly solve this example by using the derivatives of composite function. Sin inverse x का formula आप डायरेक्ट यूज कर सकते हैं 1 upon root of 1 minus x square वाला. But by using trigonometric rules, we have to solve this example in the very, very simple way. Let's see. Y equal to sin inverse. So instead of cos x, I am putting sin of 90 minus x. Now we know that the result sin inverse of sin x is x. So that's why sin inverse sin निकल जाएगा. We write down y is equal to pi by 2 minus x by using the rule of inverse trigonometric functions. तो देखिए कितना इजी हो गया. So now differentiate d by dx of pi by 2 minus x. Now what is the derivative of pi by 2? Yes, it is 0 because pi by 2 is a constant. It is not contain x. So therefore derivative of pi by 2 is 0 and naturally derivative of x is 1. So finally we get the answer dy by dx equal to minus 1. Now see the another example on the rule of inverse trigonometric. Y equal to cos of sec inverse of 1 upon x. Now tell me what is the relation between cos and sec. Yes, they are reciprocal to each other and you know that sec inverse of 1 upon x is what? Sec inverse of 1 upon x is cos inverse x. So put down in the above example. So we get y is equal to cos of cos inverse of x and by using the rule of inverse trigonometric function y equal to x. Now differentiate with respect to x. The derivative of x is 1. So finally we get the result. It is 1. Now look at the another example. So we solve all these examples on the rule of inverse trigonometric function. Now y is equal to tan inverse of 5x upon 1 plus 24x square. So already we see the result. Tan inverse x plus tan inverse y equal to tan inverse x plus y upon 1 minus xy. Now how you find out the derivative of this function? Tan inverse 5x upon 1 plus 24x square. We split these terms into two terms. देखो कैसे split करेंगे? We split like this way. Y equal to tan inverse of 8x minus 3 upon 1 plus 24x square. कैसे split किया? I am taking these two terms in such a way the difference is 5x and their multiplication is 24x square. 8 into 3, 24 and 8 minus 3, it is 5. So just you see the relation of 5 and 24. This thinking is very important. अगर आप ये think नहीं करोगे तो ये problem solve नहीं कर पाओगे. तो 24 और 5 आपको ऐसे दो वैल्यूज सिलेक्ट करना है कि जिसका मल्टीप्लिकेशन 24 है और उसका सब्ट्रैक्शन 5 है. सो इंस्टेड ऑफ 5x we write down 8x minus 3x, and instead of 24x square, we write down 8x into 3x. So finally, by using the rule, we say that y equal to tan inverse of 8x minus tan inverse of 3x. Now we take differentiation, dy by dx equal to d by dx of tan inverse of 8x minus d by dx of tan inverse of 3x. So this is just like a derivative of tan inverse x, but tan inverse x, the derivative is 1 upon 1 plus x square. In the similar manner, derivative of tan inverse of 8x is 1 upon 1 plus 8x square into again. अगर आप 8x का डेरिवेटिव लिखना भूल जाएंगे तो आपका प्रॉब्लम रॉन्ग हो जाएगा. सो यू टेक केयर. What is the difference between the derivatives of simple tan inverse x and the derivative of tan inverse of 8x? So 1 upon 1 plus 8x square into again derivative of 8x minus again the same way derivative of tan inverse of 3x is 1 upon 1 plus 3x square into again derivative of 3x. So finally we get the answer. Derivative of 8x is 8 upon 1 plus 8 का square 64 into x square minus 1 upon 1 plus 9x square into 3. So students, do you have any question?
Yes sir, I have. How to identify where we use chain rule for differentiation?
Okay, very good question. So student, basically we define two types of function. First is simple type of function and another is composite type of functions. So what is the difference? So just you have to take one of the example, log x and log of ax plus b. So log x, we have to say it is a simple function. Log of ax plus b, we have to say that it is a composite function. Now we see the derivative of log x is 1 upon x. At the same time, the derivative of log of ax plus b, that means first you take d by dx of log of ax plus b and into again derivative of ax plus b. That means this is a chain rule. First derivative of log of ax plus b and again you take the derivative of ax plus b. So now you remember how you differentiate the simple type of function and the composite type of function. Let's we take another example. Derivative of sin x is simply cos x. We say it is a simple type function. Now in the same way, derivative of sin of e raised to x. That means x की जगह पे e raised to x. That means first you differentiate sin and then you differentiate e raised to x. So sin of e raised to x is a composite function and here we apply the chain rule. Now understood?
Yes sir, thank you.
So students, to be able to use chain rule of derivatives to solve the examples on composite function. Students are understood how to differentiate simple function and composite function. Students are able to solve the examples on composite function using rule of derivatives. Now you are fully competent to solve the problems of derivatives on rules of derivatives. So worksheet is given below. Try to solve it. Now the solution of worksheet is provided for cross verification. First example, log of x square plus 2x plus 1. So first you differentiate log and then you take derivative of x square plus 2x plus 1. This is the solution. Another example, y equal to cos of log x. So first function is cos, another function is log. So first you differentiate cos log x, that is minus sin log x, and then you take derivative of log x, that is 1 upon x. Here is the solution. Another example, y equal to cos of x into e raised to x. First function is cos. Another one is x into e raised to x. So first you differentiate cos, put x into e raised to x as it is, and then again you take derivative of x into e raised to x. Here is the solution. For x into e raised to x, we apply product rule. What is the final solution? See here. Now take another example, y equal to sine log of 4x. So here we see sine is also there, log is also there, and 4x is also there. How you apply the rule of derivative? That means chain rule of derivatives. So after application of rule, you will get this answer: cos log of 4x, derivative of log of 4x, and derivative of 4x. So here is the final answer: cos log of 4x upon x. Now here the another example, y equal to log of sec x plus tan x. First you take derivative of log of sec x plus tan x, and again you take derivative of sec x plus tan x. Here is the derivative. See, you take sec x common. So see here, you have to make a common mistake here. You do not take sec x common and you directly write down the answer. So first you take sec x common, you cancel it, and then you write down the final answer. So take care here. Another example, y is equal to sine inverse of root x. So basic function is sine inverse, but instead of x, it is a root x. So it is a composite function. So first you take derivative of sine inverse of root x, and then again derivative of root x. Here is the answer: 1 upon root of 1 minus root x square into 1 upon 2 root x. Now another example, y is equal to sine of 2x degree. So first you have to convert x degree into radian. Now x degree is equal to x pi upon 180. So sine of 2x degree, that means sine of x pi upon 90. So this is not x raised to 0. This is x degree. Remember these things. Now apply the chain rule. First you take derivative of sine x pi upon 90, then you take derivative of x pi upon 90. Pi upon 90 is constant, so we take it outside and you take the derivative of x. So what is the final answer? Dy by dx pi upon 90 cos of x pi upon 90. Take another example, y is equal to log of sine 4x minus 3. First you differentiate log, then you differentiate sine, then you differentiate 4x minus 3. Here is the final answer. See carefully. 4 into cos of 4x minus 3 upon sine 4x minus 3. So cos upon sine is nothing but cot. So final answer is 4 cot of 4x minus 3. Next topic, module differential calculus, topic derivative 3.
You have learned some important topics so far, and we hope you had good time learning with us. Browse through our online library for more content on the MSBT website. Thank you. Stay connected. Happy learning.